Welcome to another coding tutorial, and in today's video I'm going to show you how to make a game of Snake. I made a series on Introduction to Creative Coding, so if you want to understand each of the concepts shown in this video, make sure to check that out. First things first, I'm going to create the board. I'm going to declare three variables: calls for columns, rows, and the size. And then I'm going to set the size to be 50 pixels. And underneath the setup function, I am going to calculate columns, which is equal to the width divided by the size, and rows, which is height divided by size. So now we have the number of calls and a number of rows. Next, we want to declare the board. And this board is going to be of the type 2D array, but with JavaScript, first you need to tell it that it is of the type array, and you can do that by writing this square bracket. In the setup function, then you need to use a nested for loop. And this nested for loop will allow us to create a 2D array. I have a whole video of how you can do this and a lot of coding tutorials to explain this, so check that out if you're not familiar. First, we want to create number of columns, empty arrays within the board, and then I want to set the value of all of the cells in this board to be 0, and you'll see why. Next, what I want to do is that I want to draw the board, but instead of just writing the commands underneath the draw function, I'm actually going to create a new function called display board. And what we're going to do is that we're going to use a nested for loop. And then we're going to use the rect function, which takes in 4 arguments: the x and y coordinates of the top left corner of the rectangle, and then the width and the height. So it's going to be I times size, j times size, and size and size. And then we need to make sure that we call this function underneath the draw loop. Then let's click play. There you go. So now we have the snake board of the size 8 by 8. Next, what we're going to do is that we're going to create the food. So I'm going to start by declaring a variable called food. And you can see that I am only declaring one variable, and that is because instead of declaring food x and food y, which stores the x and y location of the food, I will use this thing called a vector, and a vector is an entity that has a magnitude and direction. But essentially, vector is a class within p5.js that can store 2 or 3 values, but we're going to use it to store 2 values, which are the x and y location of the food. Underneath the setup function, we can use this built-in method within the vector class called create vector. And let's say I want this food location to be at 0, 0. So now underneath the draw function, I'm going to set where food is to be equals to -1. So right now, initially we set all the values within this board to be equal to 0, but where the location of the food is, it's going to be equal to -1. So now underneath the display board function, right now I'm going to say that if board of I and j is equals to 0, then fill in that color white. Else if board of I and j is equals to -1, then set it to red. There you go. And so you can see that at columns 0 and row 0, which is where the food is, it is colored red. And you can see that if I change this to 1, then it gets moved accordingly. Actually, what I'm going to do next is that I'm also going to display the values inside this board. And I can do that by, I want the text to be at the center, and then let's set the text size to be 10, and then let's set the text to be the value of the board, right? And then the location would be at I times size and j times size. Okay, you can kind of see it, it's white right now, so let's give it a fill of black. And we want to move it out by half of the size in the horizontal direction and half of the size in the vertical direction. So now you can see all the values of the board, and you can see that the food has a value of -1. But instead of hard coding the location of the food here, what we want is that we want to generate a random location for the food. And what we can do is that we can use a random function. And this random function will go between 0 and columns -1, right? We want to give it the index location between 0 to 7. And same goes for the rows, right? And if we click play, and now it gives us an error because the random function actually gives a decimal number. So what we want is that we want an integer because index value has to be an integer. So what we can do is that we can say int here. And then now you can see that the location of the food is random. But there's one missing piece. The random function actually go between 0 and the second argument, but not including the second argument. If you put cols -1 here, it means that the value that it goes will be between 0 and 6.999999. And once we do integer here, it will go between column 0 to column 6. So what we want is that we want columns and not columns -1. Same here. And so you can see now that we can have the last column here. What we want to do next is that we want to create the snake. Instead of thinking about snake as the whole snake, I'm going to think about it as its head and its tail. So let's start by creating the snake's head. So I'm going to declare another variable called head, and head, I'm going to make it also a vector. And I'm also going to give it a random location. So we can just copy this. And then board of head.x and head.y, I'm going to give it a value of 1. And then I'm going to say that else, then fill the color yellow. Okay, so now we have the snake's head and then we have the food. What do we want to do next? We want to move the snake, right? And we're going to move the snake by pressing the key on our keyboard. So if we press the left key, we want it to move left. If we press the right key, we want it to move right, and so on. So we can use a function called keyPressed. And this is a built-in function within p5.js. This keyPressed function is called whenever you press the key. We can use 4 conditional statements to identify which key is pressed and then what function we want it to do once that specific key is pressed. So let's start by identifying the key that is going to be pressed. So if key code is equals to left arrow. So these are variables within p5.js or within JavaScript that you just need to remember. So key code basically signify which key is being pressed, and then this is the left arrow, right? And then we are going to make key code equals to right arrow. And else if key code equals to up arrow. And the last one is else if key code equals to down arrow. So what do we want to do? We want to move the snake when these keys are pressed. I'm going to create another variable, and this variable is going to be called direction. I'm going to short it with dir. And direction is going to also be a vector. But instead of a random vector, it is going to be a vector. I'm going to start with 0 to 0. So with vector, so essentially direction is going to be added to the location of the snake's head. For example, let's say that snake is at 0, 0. And if I say that the direction is 1, 0, that means every time we add the direction to the location of the snake's head, then it will move to the right every pixels, right? So X location is moved 1 pixel at a time, but Y location, because it's at 0, it's not going to be moved. So what we need to do is that we need to say that direction here is going to be a vector of, so left would be what? -1, 0, right? Go to the left, and then right would be 1 to the right. For up, remember the Cartesian coordinates for computer graphics. Up is negative, right? While down is positive. So once we have this, we can move the snake's head, and we can do that by saying head.add direction. This function here basically add the x component of the vector head and the vector dir, and also add the y component of the vector head and the vector dir. It is a method within the class vector. So let's try this. So I'm pressing right. Oh, you see, I'm pressing up. I'm pressing left. So it's doing what I want it to do. I'm pressing down, but not quite. So what we want to do next, what I want to do next is that I want it to slow down a little bit. So I'm going to change the frame rate. And the frame rate, the default one is 60 frames per second, right? So I'm going to set it to 5 frames per second, so it's a little bit slower. And what you can see right now is that once it hits the border, then it gives us an error, and that is because it is trying to tell us that, hey, board of index whatever that is beyond 7 does not exist. So that's why I'm telling you that there's an error. So what we want to do is that we want to create another variable, and this is going to be a Boolean variable called game over, right? And game over will be initialized as false. And we want to set where the head is only if game over is still equals to false, right? If it is game over, which means game over is equals to true, then we don't want it to set the location here. So if game over is equals to false, then do this. But right now, I have not actually fixed anything yet. So now let's go to set the conditions when game over would be true. Next, what I'm going to do is I'm going to create a function called update. And I'm actually going to put this move function here underneath update as well. Now I'm going to set conditions when game over would be true. So there are 2 ways when game over would be true. One is that, as you can see, when we hit the border. So the condition would be if head.x is less than 0, or head.x is more than cols -1, or head.y is less than 0, or head.y is more than rows -1. Then I want to set game over to true, right? And then let's just print, also say game over hit border. Let's try this. Oh, it's not going right now because I have not called update. Okay, now it's telling us that game over when it hits the border instead of telling us that there is an error. So that's good. But you can see that right now, wherever the snake moves, all the locations where the head is becomes 1. What we want is that we only want where the head is to be 1 or to have a value more than 0. And we're going to do that by increasing the value of where the head is by 1 every time the draw function is called. And we're going to subtract all the locations of the whole board to be -1 where the value is more than 0. So we're going to do that first by saying that this is part of the else if statement here, right? So if game over is not true, then what we want is that we want to set board of head.x and head.y to add by 1. And then we want to remove tail. So what is remove tail? Let's write another function called remove tail. And basically remove tail is going to subtract the whole entire board by 1 where the value is more than 0. So we're going to use a nested loop. So if board of I and j is more than 0, then board of I and j is going to be subtracted by 1. Let's try this. But it doesn't work right now because you can see that because the head is at 1. And so every time that I start clicking the key press, then that 1 is subtracted by 1 here. So it becomes 0, right? So actually, we need another variable. And this variable is going to be called length. And length is going to be initialized at 1. And instead of giving the value here as 1, we're going to say length here. So every time that we move the board, we want to actually set the head's location to be 1 plus length. It's going to start with 2 and then it's going to be subtracted by 1. And then let's try this. You can only see the value 1 here because every time that we call 1 plus length here, we also remove tail, which subtract everything by 1. So the head right now, you see it as 1, but it's always 2 and then -1 to becomes 1. And so we now have a snake head, basically just the head that moves around. What we want to do next is that we want it to eat the food, right? And once it eats the food, then we want the snake to get bigger, right? So it's going to be the head and the tail. When is it going to eat the food? It is when the location of the head and the location of the food is the same. And we can do another conditional statement. If the distance between, and this is the function called dist, D-I-S-T, which will calculate the distance between 2 points, and it takes in 4 arguments, the x and y of the first point and then the x and y of the second point. So what we want to put in is that we want to put head.x, head.y, and also food.x and food.y. And if the distance is equals to 0, meaning that it is at the same location, then we know that the food has been eaten. And so once the food is eaten, what do we want to do? We want to generate the new location for the food, right? So we can just copy and paste this line here, down here. Let's try that. Okay, so now we have a command where the food is eaten and then the new food is generated. But what we miss is that we also want the snake to get longer, right, as it eats the food. And that is as simple as we can just increase the length, right? So length is equals to length plus 1. Or you can just do length plus equals to 1. And there you go. So you can see that because we set the head location to be 1 plus length, right? So every time that it eats the food, it just increased by 1. But did you see that? Did you just see that where the food got generated on top of the snake? That's not what we want. So let's fix that part first. How do we fix that? So instead of just writing this line here, I am going to write a new function called generate food. And this function is essentially going to generate a random location of the food, but that location needs to not be on top of the snake. And we would know that it is on top of the snake if the value of food.x and food.y is more than 0, right? Because the snake has a value of more than 0. So we're going to use this expression. It's a while loop expression. While true, keep generating the food. If board of food.x and food.y is equals to 0, then break. Essentially, what this expression is saying is that, hey, keep generating the new location of the food until that location is equal to 0, which is not on the snake, then break out of this while loop. And this will fix the problem that we have. Might be kind of hard to see because now it should not just be on the snakes, right? Seems like it's working. Okay. All right. We only have a few steps left. The first step is that there's another condition where game would be over, which is when the snake hits itself. So underneath this conditional statement here where we have that, hey, if it hits the border, then game over is set to true. Then let's set another else if statement. Else if, when would we know that the snake hits itself? We would know if the value inside the board where head.x and head.y is more than 1. Then we're going to set game over to true again. And we're also going to print game over hit itself. Okay, let's try it. So now 2, 3, 4, let's make it a bit longer. 5, 6, okay. 7, 8. Oh, it did hit itself, but it didn't stop. It did hit itself, but it didn't stop, and that even though game over is equals to true. So what I want to do is that I can set the direction to be 0, 0. So stop the snake from moving, and I can do that by using a built-in method called set, and then set the value to be 0, 0. And then now, let's see, once it hits itself, there you go, it hits itself. We pretty much have a game of snake, but I want to add the last piece, which is I want it to tell me that the game is really over when the game is over. So I'm gonna write a text in the smack in the middle at the size of 50, and I'm gonna say game over and put it in the middle. There you go. And now you have a game of Snake. You can also comment the value of the board out here. And you can also set the cells to be smaller. And you can make your frame rate faster too, if you are ready for that challenge. So let's try it. There you go, you have a game of Snake. Give it a try.